This is the lesson for Friday, September 17th. It is part of the lesson for R8, and all we're going to talk about in this lesson is just how to rationalize the denominator of a fraction. So we're going to start just by asking the question, what do you get if you multiply, say, the square root of 3 times the square root of 3? Because the square root of 3 is a radical. And it turns out that the square root of 3 times the square root of 3 is just 3. Those square roots cancel. One way there's a couple ways to see that. One way would be to say, okay, the square root of 3 times the square root of 3, if I wrote that again, square root of 3 times the square root of 3, well, that would be the square root of 3 times 3 is 9. But what is the square root of 9? Well, it's 3. So that's one way of showing it. The other way to think of it is if you do the square root of 3 times the square root of 3, you're actually squaring the square root of 3. And the square and the square root will just cancel out, and you'll be left with 3, or whatever number's under the radical. So just to give you another example, if you had the square root of 12 times the square root of 12, you could say, oh, that's the square root of 144. But what is the square root of 144? It's 12. So what you want to remember is to get rid of a radical, you can just multiply by the same radical, and they cancel out every time. And even if there's a variable, that will still work. So the square root of 2x times the square root of 2x would be the square root of 4x squared. But we know the square root of 4 is 2, and the square root of x squared is x. So again, you can see that when you multiply identical radicals, that radical just cancels out. So how does this tie into rationalizing a fraction? Well, let's look at another example. Let's say that you had something like 3, let me get a pen here. Let's say you had 3 over the square root of 5. You are not allowed to leave that radical, that irrational number, in the denominator. You have to rationalize the denominator. So what you do is we know that if we multiply the square root of 5 by the square root of 5, that we will just get 5 as our answer. But whatever we do to the bottom of a fraction, we have to do to the top. So that means we would also have to multiply the top by the square root of 5. And when I do that, the bottom, the square root of 5 times the square root of 5, is just 5. Now on the top, that 3 and that square root of 5, you cannot put those together underneath the square root sign because only the 5 is under the radical sign. So the 3 just becomes a coefficient. So your final answer here is just 3 times the square root of 5 divided by 5. You're done. Let's look at another one. So let's say you had, we'll say this is example 1. Okay, and then let's just say that we'll do example 2. And we'll say that you had, let's do 8 over the square root of 7. So we would multiply top and bottom now by the square root of 7. And we know that the square root of 7 times the square root of 7 is just 7. And that the top would just be the number 8, would be our coefficient, times the square root of 7. And this would be the final answer. You can't simplify that any further. And let's just look at one more example. So let's say you had something like this, 12 divided by the square root of 10. And so you say, okay, I got to get rid of that radical on the bottom. I'm going to multiply the square root of 10 times the square root of 10. I'm going to do that top and bottom. On the top, 12 times the square root of 10 would just be 12 times the square root of 10. On the bottom, I would get the square root of 10 times the square root of 10, which is 10. Now, if you look closely, though, you've got a fraction that reduces because 12 and 10 are both even numbers. You can't do anything with the radical. But the 12 and the 10 are both divisible by 2, so 12 divided by 2 is 6, and I still have my square root of 10. And then on the bottom, 10 divided by 2 is 5. So you would reduce those two numbers on the outside. In other words, the coefficient on the top and the bottom number, if they have a common factor, you need to reduce that out to get the final answer. Now, the other issue that can arise is that you can actually have, instead of just a single radical in the denominator, you can have a binomial. And so what do you do in that case? Just multiplying by a single radical will not fix the issue. So we need to talk about something called a conjugate. Conjugates are binomials that are identical in every way except the sign separating the two terms. So for instance, the conjugate of x plus 2 would be, let me pick a different color here, would be x minus 2, okay? Now, why do I care about that? Well, when you multiply conjugates, something very special happens. The middle terms cancel out. In other words, if I were to actually multiply this and distribute it, x times x would give me x squared, x times negative 2 would give me negative 2x, then I'd go back and do 2 times x, which would give me positive 2x, and then last would give me minus 4. And basically what happens there is those two middle terms cancel out, and so you're left with just x squared minus 4. So it turns out that rather than foiling that out, I could have just squared the first term, which was an x, and squared the second term, which was a 2, and I would get x squared minus 4, okay? So how does that work if I actually have a radical involved? So now let's look at the next example. You have x plus the square root of 2, and if I multiply that by its conjugate, that's going to be x minus the square root of 2. Oops, dropped my radical sign. Now, x times x is going to give me x squared, and x times minus square root of 2, that's a minus sign there, is going to give me minus the square root of 2. Then I'm going to go back and do the second term, which is the positive square root of 2 times x, which will give me plus radical 2 times x. And then the last term, radical 2 plus radical 2 times negative radical 2 is going to give me minus 2. Remember, those square root signs cancel out. And now the two middle terms also cancel out because they have opposite signs there. So now what you have is you have x squared minus 2, and that is your final answer. So again, I could have just taken the shortcut of squaring the first term, x, that would give me x squared, and squaring the second term. The square root of 2 squared is just 2. That's what we practiced earlier. So let's look at another one. If you have the binomial, the square root of 5 minus x, then its conjugate is going to be the square root of 5 plus x. And now we're going to FOIL this. And the shortcut would be to just square the first term. The square root of 5 squared is 5. Square the second term. X squared is x squared. And then because these signs are opposite, and they always will be because conjugates are binomials that have opposite signs separating the two terms, this will always be a minus sign right there. Now, if you just want to see that worked out again, I can do it one more time. First, square root of 5 times the square root of 5 is 5. Outside, square root of 5 times positive x is plus radical 5x. Inside, you've got that minus sign now, so it's going to be minus the square root of 5 times x. And then last, a negative times a positive x is going to give you a minus x squared. The two middle terms are opposites. They cancel out. So I end up with just 5 minus x squared, which is the same thing I got when I took the shortcut. So you do not have to FOIL it all the way out. Now we're going to take this method and apply it to some problems. Okay, so let's look at an example where you have a fraction, and on the bottom of that fraction you have the radical square root of 3, and you have to rationalize that denominator. Since you just have a monomial there, you literally can just say multiply, and the square root of 3 times the square root of 3 I know will cancel out. So I'm going to multiply both the top and the bottom by that radical. On the top, 1 times the square root of 3 would just give me the square root of 3. Now on the bottom, the square root of 3 times the square root of 3 would give me just 3. Those radicals cancel out, and you're done. Now the second one, number 5, if we look at that, we really, again, the only radical, this is still a monomial here. There's no plus or minus sign there. So you can just multiply by the radical, which is the square root of 2. That coefficient of 4, you have to keep track of it, but you really don't have to worry about it too much in terms of what you're going to multiply by. It won't change that. We'll just multiply by the square root of 2. So on the top, 7 times the square root of 2 will just stay 7 square roots of 2. Put your fraction bar. 4 times the square root of 2 times the square root of 2 is 2. So really what I have now is 4 times 2, right? But I know what 4 times 2 is. It's 8. So I'm going to clean up the bottom and then recopy the top, 7 square root of 2, and I'm done. You cannot reduce that. Even though 2 and 8 have a common factor, the 2 is underneath a radical, so that does not reduce, okay? Now let's look at one where it's a binomial on the bottom with a radical. So what you're going to have to do here is you're going to have to multiply by the conjugate of 2 radical 3 plus 4. And the conjugate of that is going to be 2 radical 3 minus 4. So 2 radical 3 minus 4. And I'm going to multiply the top by that also, 2 radical 3 minus 4. Now, let's see what happens here. On the bottom, 2 times 2. So I'm doing this, 2 times 2. And the radical 3 times radical 3. Well, 2 times 2 is 4. And radical 3 times radical 3 is 3. So I have that. I know that the sign is going to be opposite because a positive times a negative is a negative. And now literally I don't have to worry about the outside and the inside. Those are going to cancel. Now I do still have to do the 4 times negative 4, and that's going to give me a minus 16. I'll clean that up in a minute. Now I'm going to go to the top, and I'm going to do the square root of 5 times each of these terms on the top. The square root of 5 times the square root of 3 is the square root of 15, and I still have that 2. So I'm going to get 2 square root of 15, and then the square root of 5 times 4, and then it'll be a minus sign there. So minus 4 times the square root of 5. We always put the radical second, okay? Now I still have to clean up the bottom a little bit. So on the top, I have 2 times the square root of 15 minus 4 times the square root of 5. I can't do anything with that. On the bottom, I have 4 times 3, which is 12. This is 12 right here. Minus 16. 12 minus 16 is negative 4. Now, if you look, the numbers outside, you can't do anything with the radicals, but the numbers outside the radical, they all have a common factor of 2, so I can divide through by 2 here. So 2 divided by 2 is 1, so I'll just have the square root of 15. I'm going to have my minus sign. 4 divided by 2 is 2 times the square root of 5. And on the bottom, 4 divided by 2 is 2 again. And there was a minus sign there, okay? Now, you could divide through that minus sign, and that would just flip the signs on the top. I'm not going to mess with that. I'm just going to leave this the way it is. This is reduced, okay? So this should get you started. I'm giving you a few problems to work on over the weekend or Monday. Come see me if you have questions. Here's the assignment. It's on page 79 in your book. It's due Tuesday by midnight. You can certainly come see me on Monday if you have questions or need help. And we can talk about it in class on Tuesday also. Have a good weekend.